Can two students from the same school, the same grade, the same section have the same roll number? No, because every student has their own identity. If I randomly pick two of you people watching this video, you can be from two different schools, you can have two different sections, whatever, so on and so forth. 4 pieces of information, and they pinpoint exactly one person amongst all of you watching this today. That is what electrons do as well. Each electron in each and every orbital, in each and every atom, has its own identity. 4 unique pieces of information that signifies that this one electron is present in this one orbital, in this one atom. This isn't a random convention or rule that we normally see in physics and chemistry. This is fundamentally present within nature, and we understand these 4 pieces of information to be quantum numbers. So today in this very short video, I'm going to tell you everything about quantum numbers, what they are, what they signify, and why do we require them to understand atomic structure and the behavior of electrons as a whole. You know what, just to give you people a visual, let's imagine a building and let's consider this to be analogous to an atom. Each of these buildings have multiple floors. Each floor has specific kind of rooms, and each room has a specific orientation. Let's say this building is the atom, and each of these floors of this atom, the shells, has each of these kind of rooms, subshells, with different orientations, orbitals, and each orbital fits in one electron in one direction. You see, what have I built up? I have given you 4 pieces of information: the floor, the room, the orientation, and the direction. These are the 4 quantum numbers we are dealing with today. Let's start off with the first one, the principal quantum number. What is this? What are we dealing with? This is the most important quantum number because this tells you the energy level. Building example dekhna tha, so it was telling us the floor. So each electron occupies a certain energy level. And why is that so? That goes back to our understanding of quantum physics as a whole. Whenever you start studying quantum physics, be it via your physics syllabus or your chemistry syllabus, we understand that at such small scales, we are dealing with discrete energy levels. ये तो diagram हमने देखा होगा. So each electron overarchingly is present in one of these discrete energy levels. If you are at the ground state, you are at n is equal to 0. That indicates the lowest energy level. N equals 1, one step higher, first excited state. 2, 3, 4, you can go up higher and higher. So say if I want to designate it by the Bohr's model talking about shells, I can say n is equal to 1 talks about the K shell, 2 is the L shell, 3 is the M, so on and so forth. Fair enough. So now within these energy levels, if I were to subdivide on the basis of subshells, how do I determine that? That I determine using the azimuthal quantum number. Building example में हमें क्या बता रहा था? It was the room in the floor. This tells us the subshell it occupies. More appropriately, it tells us the shape of the orbital. Why is this important? Now, for all of you people studying quantum physics or chemistry, it is important for us to know that each of these orbitals can be showcased as a plot of its probability density. इसका मतलब क्या हुआ? What is the probability in 3D space to find an electron? So, if I have an electron possessing a particular azimuthal number, I automatically know whether this is my probability range or this is my probability range or so on and so forth. It gives us the probability density of finding that electron in 3D space. So, bringing it back to the idea of subshells, if my L is equal to 0, I'm dealing with an S shell. If it's 1, it's P, 2 is D, and 3 is F. Now, extremely importantly, the range of L for any given N is from 0 to N minus 1. Yani kya? Say my electron has an energy level of N equals 2. तो उसको कौन से orbitals available हो जाते हैं? The ones corresponding to L is equal to 0 and L is equal to 1. Yani, if it is occupying the energy level of 2, ये S orbital में भी जा सकता है, ये P orbital में भी जा सकता है. So, there is that. Now, we know that कोई तो इलेक्ट्रॉन कोई तो एक एनर्जी लेवल में है और उसका ऑर्बिटल का शेप कुछ तो तरीके से है. I have an electron at some energy level occupying some orbital with a distinctive shape. Now, what's important for us to understand? Say if I have an orbital that looks like this. How do we know how is it oriented in 3D space? Is it along the x-axis, y-axis, z-axis? We don't have information about that. Till now, we've just looked at the energy and the probability density. I know that there is a particular way that the probability density is spread around. I don't know in what direction. So that is given to us by the magnetic quantum number. बिल्डिंग एग्जाम्पल मैंने क्या बोला था? हर एक रूम का अलग अलग ओरिएंटेशन होता है. Every room has its own orientation and this magnetic quantum number tells us the orientation. The range of your magnetic quantum number for any given azimuthal quantum number is from minus L to L. यानी क्या? Let's say that my electron occupies a certain p orbital. My electron occupies a certain p orbital. It can occupy 3 different orientations. Something corresponding to minus 1, something corresponding to 0, and something corresponding to 1. Arbitrarily, let me say this is aligning to x-axis, this is aligning to y, and this is aligning to z-axis. तो इससे मुझे आइडिया मिल गया कि मेरा कोई तो एक इलेक्ट्रॉन कोई तो एक एनर्जी लेवल ऑक्यूपाई कर रहा है एंड उसमें कोई तो एक शेप है ऑर्बिटल का, वो शेप कोई तो तरीके से अलाइन है. I have an electron which occupies some energy level having a probability density mapped by a certain shape oriented in a certain direction. Till now we have reached this point. One very important fact is that each orbital, regardless of its shape, regardless of its orientation, can occupy only 2 electrons. And those 2 electrons must be in different directions, quantified by the spin quantum number. Spin quantum number कोई भी इलेक्ट्रॉन के लिए it's either minus half or plus half. No other option. So if I have an electron and I've been given all of these 4 quantum numbers for it, I can tell which energy level it possesses, what is the shape of its orbital, how is the orbital oriented, and what is the direction of the spin of the electron within that orbital. That is what we have understood till now. Certain important formulae that I could highlight. If say I want to know the number of orbitals that any subshell can possess, it is going to be 2L plus 1. If I have been told that I am dealing with the S subshell, L is equal to 0. If I substitute that, I only get one particular orbital, meaning I have only one particular orientation. Substitute for L is equal to 1, the p orbital, and I have three possible orientations, three possible orbitals. So ये अभी तक हम पहुंचे हैं. If I'm telling you that no two electrons can have the same four quantum numbers, I am trying to put it into your head that every electron is unique. ये principle जो है is Pauli's exclusion principle. And this itself states that no two electrons can possess the same four quantum numbers. So let's take a couple of questions. If you are able to access the quiz feature on YouTube, you may put in your answers then and there itself and you will get your correct answer. Which of the following set of quantum numbers is not possible? You can see your four options on the screen. Think about it, pause the video. If the quiz feature is available, answer there or else put it in the comments. If I have a chlorine atom and I want to make it into Cl minus, I'm adding in one electron. What will be the four quantum numbers for this additional electron? What will be the four quantum numbers for this additional electron? Your options are on your screen. Either put it in the comments or access the quiz feature right now. So to summarize all of whatever we've discussed till now, each electron can be identified by the four quantum numbers that it is characterized by. The first one, principal quantum number, tells us about the energy level that an electron possesses. The azimuthal quantum number tells us about the shape of the orbital or the subshell it's present in. The magnetic quantum number tells us about how this orbital is oriented. कितने possible orientations हैं और उसमें से वो कहाँ बैठा है. And finally, the spin quantum number tells us about the direction in which the electron is rotating about itself. No two electrons can share all the four quantum numbers. That is Pauli's exclusion principle. So all in all, here is where we stop for this particular short video. In these coming few videos, we'll be discussing a lot more about chemistry, physics, biology, mathematics, and all of that. So subscribe to this channel. And if you're interested in working with me and my mentors one-on-one to personalize your learning journey, schedule a learning audit right now. It's completely free and you get absolute amazing access to your own learning journey, to your own learning plan to achieve your learning goals. So I'll be looking forward to seeing you all there. With this, see you in the next one.